So, welcome to day seven. This is where we are starting our journey on analytics services on AWS. And idea is I will show you like how you can build a data lake in AWS by using various AWS services. Till now, we have covered foundation of AWS services, around storage, networking, access management, which comes very handy when you work with AWS. Uh, okay, so even before going into data lake, and I will try to have like almost four or five session around data lake where I talk about all various services which involve in building data lake and try to go deep. And I know most of you are new to AWS, so if you ever feel okay, you're not getting the concept, or you're not able to uh, if you're not able to grasp the concept, just feel free to interrupt me and ask any question in between. Okay. As always, let me start saying all the opinion expressed by me in this video are solely mine and has nothing to do with my employer. So we talked about data lake, right? And even before going into data lake, what data lake is, just let's learn about why we need a data lake in very first place. And so as we all know, right, the data paradigm is changed. We used to have a computer system where we only used to have couple GB of memory. Now we have a mobile which is super powerful, and with 16 GB of memory or even more than that. And earlier we used to have a data sources, only traditional data sources like your relational databases or maybe some flat file. Nowadays you are generating data from everywhere. So if you go, I mean, if you just read this slide which I'm showing you, it's a mind-boggling, right? It's showing like, okay, we have almost 500 million tweet every day, 4 petabyte of data created on a Facebook. Just think of like 300 million photos being uploaded or kind of being uploaded on a Facebook. It's a huge, right? And 100 million hours of video watched. So it is really huge, and what people are expecting, we are going to have 44 gigabyte of gigabyte of storage by 2020. It means we are already in 2020. So you can just think of, right, in 2013, 4.4 zettabyte of storage was used. Now we are having 44. It means 10 times in just 7 years. Okay, so what is telling is now data is being generated by each and every one of us and each and every devices, and it will get exploded as well eventually when we start having all those connected cars, right? When we are having all those connected devices, we call it IoT, Internet of Things. When I leave my office, I just tell, okay, just turn on the AC and have a temperature maintained, something like that. It means because everything will be connected. And one things which you have observed is the company which able to get value out of data is a market leader now. I can give you an example. Just think of Lyft or Uber, right? These guys do not own single cars, but still they run biggest, I think one of the biggest uh, transportation companies. And just because of the data, they just manage the data. Uh, look for uh, look for Airbnb. Airbnb is, they do not own a single hotel, but they run the biggest hotel chain in the world. So the idea is all these companies are able to extract value out of data. So there is a phrase called data data is nothing, and data is useless, and when we take a value out of it, then it's meaningful. So this is why, and like when we have like that such huge amount of data, company is looking to store that amount of data, and they do not want it to discard any data. The reason being, you never know which use case arrive in future, and now more and more regulatory things is coming out, and they wanted to have the data stored. So they wanted to provide customized customer experience, and all these companies are working on it. Just look at, like, when you search something on internet, and all of a sudden you bombarded with all kind of internet. So just think of like how much data is being collected, and how the data is being served for us to provide a better user experience. So this is where the concept of big data come into picture, when we have a humongous amount of complex data, you know, uh, being generated, and then there is a lot of different varieties of data. So I will talk on that in a couple of slides. So I talked about huge amount of data, and we call it big data. So just let me tell you, just do not get confused between the big data is okay. When I have like exabyte of data or zettabyte of data, then only is going to be a big data. If we talked about big data as a concept, it's like, okay, when my machine is not able to process the data which I have, we call it big data. For instance, if I'm having uh, a Mac with if I'm having a Mac, let's say 16 GB of memory, and I have 20 terabyte of data in it, so my Mac will be not able to process that much amount of data. So for that Mac, it will be big data. But if I have a machine where I'm having like 20 terabyte as a compute power, and I'm putting 20 terabyte of, or maybe 100 terabyte of data into it, and if it's able to process it, it's not going to be big data for that particular machine. So it's a kind of a frame of reference, but again, it's a representation of a huge amount of data, and that which required complex processing. And there is if you see here in this slide, what I did is I have highlighted this data processing. So because at the end, you can have as much as data you want, till the time you're not able to process it, right? You're not able to get meaning out of it. So, and as I said, right, data is meaningless, and information has all the value. So in order to get the information, you have to process your data. So the data process is like collection and manipulation of your data is called the data processing, right? To get the meaningful information. Uh, yep. So once we have a big data, right? Big data comes with the big challenges. So let's understand what all challenges which we have with the big data. So first challenge having the big data is storing, right? And as the data is a different type, right? You cannot. Let me mute someone. Okay, thank you. Okay. So I was saying, right now the data is being keep changing, right? And storing the data is a difficulty. Now every company generating so much data, they're getting data from their transitional databases. They're getting data from their means if they're using IoT, they're getting data from multiple sensors. They are getting data from the social media feed. They are collecting the stream click stream data, etc. So it is like, and with this much amount of data, it's like, there's always a challenge to collect the data. And collecting the data is one challenge, and other is like generating that insight in a timely manner. And just if you see here, I have just not generating an insight. Means you can generate an insight, but if you're not generating an insight in a timely manner, then it's not in use, right? And as I said, like data is meaningless, information has all the value. So generating the insight from your data is a key, again, it's a key and it's a challenge too. Thereafter, integrating all kind of different data sources which you have, and integrating those data sources and put into say a common platform, and then generate a value out of it. This is also one of the business challenge people are trying to solve. And the company who's able to achieve these challenges or who overcome these challenges are the one who's leading right now. And thereafter, validating the data is, I think, this is one of the biggest challenge people usually face, right? And you can store as much as data, you start generating insight and everything, but how you can validate, okay, the insight which you're generating in your data uh, is actually valid. So validating is a key. And thereafter, securing and auditing, right? Now you have tons of data and you have tons of people are accessing the data, but some data are super sensitive, and you wanted to secure the data from your internal user, from the external hackers, or then again, storing that much of data and putting security on top of it, then again it's bringing a lot of challenge. And thereafter, you have to plan for your data growth, right? So as I told you, right, there was a 4.4 zettabyte of data being generated in 2030. Now we are having 44 zettabyte of data being generated in 2020, 10x fold in 7 years. So kind of putting um, managing or having a system which can deal with that much of data growth, and all those tools which actually accessing the data is able to deal with that data growth. Again, it's a business challenge. So how we can solve that problem? So there is a concept called data lake for us to solve this problem, right? And let's learn about what is the data lake. So data lake is nothing but a storage system, okay, which allow you to store all kind of data, whether it's a structured data, unstructured data, semi-structured data, etc. Means you can have a video stored, you can have your MP3 store, you can have XML file store, ZZip file store, flat file store, JSON, Parquet, Avro, any kind of file store, or maybe you're storing your relational, maybe you're bringing data from your relational databases, maybe you're bringing data from your clickstream data, maybe you're bringing data from your web servers, maybe you're bringing data from your relational databases, etc. And what you're doing is kind of storing everything in a single place. Why you want to store it in a single place? So you can able to analyze those data by using various tools. Like you can use either analytics tool, you can use machine learning tools, etc. for you to analyze those data. And there's a various advantages of data lakes, and we're going to learn on that one in the next next couple of slides. So, but before that, let me take a pause and allow you to ask any question if you guys have. Okay, it's look like there's no question, so I'm moving forward. Okay, so the key attribute or the key advantages of having the data lake is, right, first of all, you have all the data in a single place. What does it mean? It means you are avoiding the data silos, which usually company have it in a legacy world. So what is data silos is like, okay, there's a business unit, they have their own use cases, they started working it, they collected all the data, they build an awesome solution on top of it. There's another business unit. They're trying to solve the same problem, but they do not know if the data exists or not. So what they're doing is now they again started building everything from scratch without even aware of, okay, there's another team who already built, who already built that solution, and they already have the data. So what data lake provide is provide all the data in a single place, so it avoids the data silos. There is another very important concept is decoupling, right, between storage and compute. So what decoupling means is like you can store as much as data, even worry about how much compute you need. So in the legacy world, if you guys are able to correlate, right, if I have to store maybe multi-terabyte of data in my machine, I need a bigger machine with very high compute power. But with the data lake, you have not to worry about. You're just storing all the data in a cheap storage like S3, and then you are using like different analytics tool to process the data, and based on how much data you need to process, you're just choosing the tool which is required, right? So we call it decoupling between storage and compute. There's another concept called schema on read. If you're related to databases, right, what you usually do is, if you have to insert in something into your database, or if you have to store something in your database, you go ahead and create databases, and then within database you create table, and thereafter you write some kind of store procedure or any ETL job for you to ingest data into your tables, right? That's how usually process work. Or maybe your application writing into databases, but again, you have to define the schema in upfront. What data lake allow you to do is, or enable you to do is, you only need to define the schema when you are reading your data. It means you can bring any kind of data and store into your data lake, and then when we are reading the data, we are defining the schema. And on down this, in our upcoming sections, I will working on all this concept which I'm showing you here. Okay, I will be bringing the data from different data sources, kind of, decoupling the storage and compute. I will show you like, okay, I have stored this much data, but I'm just kind of, processing this much data. And for that, I'm using, very small machine, etc. Schema on read, I will show you like what is schema on read. And because of this, all this attribute, data lake allow you to perform a rapid ingest and transformation. So as you're not worried about creating that schema up front, as you're not worried about, having the big machine for you to store your data, you can just, ingest all kind of a data and put into single place. So this make like ingestion and transformation is super fast in a data lake. So when we talked about data lake, right? So there are typical steps which is involved in data lake, and actually this is more kind of a ELT, extract, load, and transform, as compared to we used to have a ETL, right? So data lake follow the concept of ELT. You are extracting the data, you're loading the data, and based on your need, you are doing a transformation. So there are multiple data sources. You collect all those data sources, you store the data sources, you process it, analyze it, and at the end, you are consuming it. So these are the broad cycles which we have in a data lake, right? But when you build a data lake, right? So there are a couple of conceptual, I can call it, things which you need to keep in mind, and when you're designing your data lake, or maybe you can call it design consideration, right? First is, okay, you have a kind of a system, or you can have a storage type which allow you to store any kind of a data. In AWS, we have a S3, which is your block storage, right? Sorry, it's an object storage. So being it's an object storage, you can store data from your Oracle, you can store data from Salesforce or any other third-party data source. So you can you can have the data and being stored in your data lake. And thereafter, we are having multiple tools which allow you to explore the data. So when you're designing your data, right, you ensure, okay, the data is being kind of, will come in different format. It can be either real time, it can be either batch processing. So what is real time and what is batch processing? Let me explain you. Real time, I did a tweet, and it being kind of gets stored, and I analyzed it. Okay, whether it's a there's a positive tweet or negative tweet, right? So it's more kind of a real time analysis. I just launched a brand, and I wanted to see that people reaction around my brand. Okay, how people are telling me about my brand. And if people say, okay, this is beautiful, this is good, this is nice, it means people are saying people have a positive opinion around my brand, right? Or if people saying this is bad, this is not working or something like that in that nature, right? It means it's a negative sentiment. But what you're doing is you're just collecting all the data in a real time and doing analysis on top of it, and letting you know, or letting your end user, means letting your business know how that how things is performing. It can be a tweet, it can be your IoT device, right? Lot of medical companies, they work and they do on a real time analysis, right? They monitor their devices and see, okay, how the devices is performing, so they able to send their technicians, okay, in order for them to fix it, or they able to report if something they see any abnormality around their machine, they able to report that machine to the doctor or the technicians, okay, go and fix it, or maybe just update doctors, okay, do not use this machine because it's abnormal performing, is giving some abnormal behavior. Batch processing, in other words, is like we are collecting the data, we are putting into somewhere storage and doing analysis of it. uh, in both the things, like, okay, we are doing analysis, but there is something called, there's a terms called latency. In a real time, your latency is in seconds, or maybe in milliseconds. In a batch processing, your latency is somewhere in minutes to hours. So that's where it's come into picture, right? What is your latency requirement? If your latency requirement uh, is less, you're trying to generate the near real time analysis. If your latency requirement is more, you're generating almost a batch processing kind of analytics. And data anonymization and security. So let's say you're a medical company, and you're collecting a lot of data, right? But you do not want it to expose your data to your analysts, so they can get to know about the patient information. So what you want to do is you want to put some kind of a masking around your data, so your data is being hidden, but still they have all the data for them to process it. I mean, for them to perform their analytics. So this way they're able to perform the analytics. Like, let's say they wanted to do the sales analytics. Okay, how's my hospital is performing? Or maybe they wanted to say, like, okay, how many people have a cancer? So what usually people do is they just maybe just remove that, or randomize that customer name to something hash key or something like that, and then letting analysts perform that all other things, because they do not need to know patient information or patient address for them to perform their analysis. And then putting the security. You do not want it to have a HR data or salary data being accessed by all the employee, right? So you wanted to put a security on front of it. Uh, the other is like the enterprise and global scalability. So you wanted to have your data lake built in a way which cannot be overwhelmed when there is a search, when there's a surge in the demand. For instance, Zoom, right? When after COVID-19, all of a sudden Zoom got a huge demand, and if they have a scalable system, they could have like not able to serve all of us, right? You just think of like how many people are using Zoom meetings this day. So you wanted to build your system in an enterprise grade with the scalability right in it. So that's a key design consideration when you're planning to build your data lake, and you have to ensure, okay, all these practices has been followed. The other one is solution consideration. Like, okay, when you're building your data lake, right, what you want to do is, okay, you just decouple everything, build on phases, right? Build one data pipeline, perform testing and everything, and see, okay, how it's performing. before even going into the next one. I have seen people, kind of bringing everything and then it's not working as expected. Then they have to kind of re-architect it. It's better, okay, just start with the one data source, bring it, complete your pilot, see it, if everything's working fine, then move with the next one. Definitely, you have to comply. You have to ensure, okay, you are following all the complying which you have within your organization, or if there's any government compliance which you have to follow it, you're following it. Okay, means, and again, this is more like, okay, if you have a like 10 use cases, just prioritize which use case which you wanted to have it completed first. And then also you have to think of long-term cost effectiveness. So when you build your data lake, there's the one thing is very sure, you're bringing a lot of data in it, right? So you want to design in a way where you can, only processing the data which you need. And if you're not processing the data, you are feeding back into your data lake and storing there, because the data lake storage is really cheap. Okay, I will take a pause here and let you guys ask any question if you have here. Okay, perfect. So this is usually the reference architecture. How that. Okay, yeah, sure. What question you have for the real-time data? How we can validate the data? That's a really nice question actually, and I don't know, man. So it's totally depend on what is your company's validation policy look like, right? And so real-time data is just not only the tweet data, and again, you do not want to validate the tweet data. Maybe you are having machine data, right? And you put some kind of a machine learning algorithm to check anomaly in your data. And uh, anomaly of data is like, okay, I used to have sales of $10 every day, and all of a sudden I see like there is a spike and I'm having $1,000 sales, right? It's a kind of data anomaly. So there is a various machine learning algorithms which help you to validate your data, to check, to help you to predict any if there's an anomaly within your data. And then there is a fuzzy match is there. Means there are tons of algorithms is there which help you to do data validation. Did I answer your question? Okay, perfect. Thank you. And yeah, so this is the reference architecture, right, around the data lake, where you are having all kind of a different data sources, and you are ingesting your data either through the ELT, ETL. You're building the real-time pipeline to ingest your data, or you're using some kind of a API, or you have data stored in SFTP, or maybe you're having the messaging data. And what you're doing is like you're putting everything into a raw zone. If you see here, right, I have mentioned sandbox as well as serverless. So sandbox, and the reason being, I do not want it to be very specific to AWS. So sandbox is like, okay, if you're using Hadoop, and nowadays not many people use Hadoop. Hadoop is built on the sandboxes. Sandbox is nothing but a collection of your VM boxes or virtual machines, etc. Serverless is more your S3, because anyways you're not managing any server and you're just putting all the data in there. So yeah, first when you bring your data without making any transformation, we call it raw zone. So this is where you put all the data, and the characteristic of raw zone, you do not want to put any ETL on top of raw zone. You just want to have the data being stored. For the ETL, you want to either use curated zone or the user zone. So let's say, I have to do sentiment analysis around my data. I'm bringing the data, storing into my raw zone, right? I mean, I'm bringing the data from Twitter and storing into raw zone. And from where I just put some kind of a transformation against my data. Maybe I'm just extracting all the text from that tweet, and I'm putting the extraction of the tweet into a curated zone. and this is where I put some kind of a machine learning algorithm for me to do a sentiment analysis, right? And so this is where a curated zone or user zone come into picture. So let's say I have a generated sentiment around various reasons, maybe US, Latin America, or maybe Asia, or other all other regions, Africa or Europe, all other regions, right? And that I have generated. Now I have users, analysts from the various location they wanted to access the data. So I just gave them data for Europe. People from Europe got their data, from Asia got their data. So this is how this multiple zones defined. There's no fixed pattern, but there's always you wanted to have a raw zone, and this is more kind of a best practices when you build your data lake. On top of data lake, you wanted to definitely build a search capability, because right, you are storing tons of data in your data lake, and if you do not have some such capability, your data lake becomes data swamp. So all the data in there, but you do not know how to extract the data and how to search the data. So having that search capability is super important. Thereafter, data quality and metadata management. Remember, I talked about. So this is where we're going to learn, and various tool how you can do that, and means I will tell you when I'm going towards all those services. And on top of it, like you wanted to enforce data security. This is very key to your data lake, because now you're storing all data in a single place. You just wanted to ensure how data is being isolated, how data is being safe, and if someone is accessing it, whether that is a valid user or not. So you're performing all kind of authentication. If there's a critical data, if there's you wanted to encrypt the data, and same with the, like if there's a PII, some kind of a data, you wanted to mask the data, and etc. Once then you wanted to do a data federation. Data federation is nothing but it's just like accessing multiple data from a single place. You wanted to perform some kind of a ETL, ELT against it, or you wanted to access your data through APIs, through SFTP location, etc., etc., etc. So these are the data consumption, right? This is how you wanted to consume your data. Once for the consumption, you can either creating a report, or performing that you are accessing your data through mobile app, web app, etc., or maybe you are building some kind of a SaaS services, or etc., etc., right? Or maybe you're using some kind of a third-party APIs for you to access the data. So yeah, so there's a lot of terms in there, and over the period of time, we're going to learn, how we can use or leverage different AWS services to perform all these actions which I have mentioned, or which is there in the data lake reference architecture. And I will take a pause and let you guys to read this slide one more time, because even for the job, if you're preparing for a job, right? Nowadays, all the companies ask you about and questions around data lake, or maybe around data, and understanding these concepts is very, very critical if you're looking any job in field of analytics, right? So, and just read this slide and ask any question if you have. So the question is, for the API calls, what is the best workflow or Python API call in terms of efficiency and processing? Okay, so for the API call, again, right? It's totally depend, right? Based on the organization to organization. I have seen people using Python too for the API call. I have seen people using JavaScript for the API call. I have seen people using Ruby on Rails for the API call. So it's totally depend. And I frankly, I did any performance comparison between this various programming languages for your API call. So I'm not sure which one is the best. But most of the time, people actually use Python for the API call. Okay, let's go next. Okay, so this is I talked about in general. Now let's learn how you can build the data lake and what all tools are available on building a data lake in AWS. So remember I talked about, so in AWS we have something called S3 where you wanted to store all your data, right? And for the real time, we have something called Amazon Kinesis. It has multiple flavors. We're going to learn deep on Kinesis. For the ETL, we have something called Amazon EMR Elastic MapReduce, which is kind of a cloud version of Hadoop. And we have something called AWS Glue, which is your AWS managed ETL service. So we're going to learn Kinesis, over our couple of in next couple of sessions. We're going to learn around Kinesis, EMR, and Glue, how to ingest data and store into raw zone. I have already there was a session where I had kind of covered that AWS Lambda, so I'm not going to cover AWS Lambda. And then thereafter, you have something called step functions, which help you to orchestrate your job. What does it mean? Orchestration is like, okay, when you have a multiple ETL job, which is kind of dependent on each other, you wanted to have some kind of flow to it, right? Maybe when you ingest data, and once the ingestion data, thereafter you wanted to fire a new job to process the data, and once the data processing is done, you wanted to do some kind of cataloging on top of it. So that's where the step functions come into picture, and there is something called AWS Workflow, which also help you to orchestrate, but within AWS Glue. So you have not to worry about that part for now, at least. For the analysts, like you can have a EMR, SageMaker, and then also Athena, right, and Redshift, Aurora, uh, Elasticsearch, etc. So these are the tools, and when I will work on the use cases, right, I will I will go more deep on this use on these tools. Thereafter, you wanted to have a security, data cataloging, and monitoring. So there are various tools, right, which you can use for those purposes. And thereafter, right, we talked about, okay, how you can access your data by various means. So if you wanted to do an API call, you can access through that API gateway, or maybe you want to access through JDBC, or you wanted to access through SQL, etc. And thereafter, we're going to learn, right, okay, what all tools are using, maybe BI tool, okay, we have something called QuickSight for you to visualize your data. For the data science, we have something called Amazon SageMaker Studio, which help you to perform some kind of machine learning practices on your data lake. And so there are many. I will try to go as broad as possible. Means try to cover, but covering all those services is definitely not going to be possible. So I will see, like, okay, if I'm able to cover a couple of use cases. One is bringing the real-time data. One is bringing the batch data. One is performing some kind of a sentiment analysis around real-time data, or maybe some kind of analysis around the batch data, and accessing through different tools. So this is all about data lake on AWS, and in our upcoming sections, I'm going to go deep on each of this layers. Okay. One thing which I have observed and would like to mention here, and will be helpful for your interview if you're interviewing for any data position. Usually people get confused between data lake and data warehouse, and a lot many people will ask me this question. Okay, we have a data warehouse, and why we need a data lake in very first place. So remember I talked about key attribute of a data lake, and this is where all the data warehouse lacks. So data warehouse is your relational transactional system. It means it required a predefined schema, and you can only bring certain kind of a data into it. whereas your data lake is non-relational, and means you can bring the relational and non-relational, means structured and unstructured data, and store in there. Okay, here you have a schema on right. Remember I talked about, okay, in a transactional system, you have to define table definition upfront for you to ingest the data, whereas in a lake data lake, it's a schema on read. So you have not to define any schema upfront for you to ingest data. Price, definitely it's an expensive because it provides you low latency. Data lake is cheaper because again it's just a storage system, nothing else. And when you put some kind of processing on top of it, then you have to pay extra for the processing. But storing data is really cheap. Here the data quality is high because again when you're inserting data, you are doing some kind of transformation against your data and then putting into your data warehouse. Whereas in data lake, you're just putting any kind of a data. You're not doing the data quality in very first place. Data analysts usually around business analysts use it and for their dashboarding. And data lake is being used by all kind of users, by business analysts, by the data scientists, by data developer, data engineer, etc. And remember, I talked about you can use a PI tool as one of those sources as a data lake, means for the data warehouse. Means you can have a Tableau, you can have a QuickSight, or you can have a Power BI, any other BI tools. For the data warehouse, you can have a multiple machine learning tools, ad hoc query, and you can do predictive analytics and etc. etc. I think what I will try to do is I will try to cover a couple of machine learning, if time allows, right? I will try to cover a couple of machine learning use cases as well. So this way you will be able to kind of visualize how end-to-end solution works. Having said that, right, as most of you know, I put extra effort for this session so I can help my friend, so to donate her on her NGO, right? So this is the reason I have started this YouTube session. So I have a friend, she is like, she has her non-profit Karma Foundation, and they are working for back in India, right? They're working for migrant workers who's kind of affected with the COVID. So here are a couple of pictures. They are just providing them food, they are providing them clothes, etc., etc. And I will be, it will be helpful. Or I have requests to make, like, if you guys able to donate to, to this non-profit, that would be really helpful. Yeah. So having said that, I will take a pause and I will let you guys ask any question. What if I would like to join it? The non-profit? Okay. Uh, who's on mute? My mic is on mute. Let me unmute you, Manik. You can. I mean, there's a. I can share the link in my video description, right? So there was a question like how someone joined this non-profit. So I will share the video, the link of Facebook page, and she's from California only. She's in from Bay Area, but usually she go and work on the ground. And so you can just connect her over Facebook, and she's on LinkedIn as well. So I think the Facebook will be the best method to connect with her. Okay. Yeah. And hey, Manik.
So I had a question, Navneet.
Yeah.
So I was thinking, if using data lakes, is there a kind of a capability? I haven't used it. Might be asking a really dumb question, but so can we use data lakes for visualization? What I'm thinking is getting real-time status of your stories, of your tasks from Jira, and using that data, real-time data in data lakes to visualize, how is the team performing, using it for predictability, using it for metrics. Basically, Jira does not have a lot of capabilities in terms of visualizing lot of data, metrics, data points, which you can use to show to the leadership as to how the different teams are performing, how a program is performing. So I was thinking if that is possible in real time, can we do it? I mean, based upon your knowledge and experience, do you think would that be something possible using data lakes?
Yeah, why not? So as long as you're able to extract the data from the Jira, right? I don't know. I don't have an idea how to extract the data from Jira because I've never worked on extracting data from Jira. So as
So
long as you're able to,
you can definitely pull using Excel, but that's a kind of a dump. That's not real time, right? So I don't know how real time would that be possible.
okay.
Someone saying you can try Alteryx.
Yeah, so there's something called Alteryx, which posted on chat. So you can try something on Alteryx, and maybe Manik, we can work on your use case over the period of time and extract the data. I don't know, means I don't have a Jira up and running, so I can't show you the demo. But as long as you're able to extract the data and put uh, into your data lake, right, and then you can do a real-time analysis. So extracting the data is a challenge, and if you're able to extract the data, put into data lake, and then you're able to perform that in real time. And then again, right? So there are a
So
couple things, right?
yeah,
Uh, for your use case, I don't think even you need a real time. Why you need a real time status on how people are performing, right? Maybe you can have a latency of 10, 15, 20, or half an hour. Even your use case do not fit into real time analysis with category.
because the status on the stories keep changing, and
Hmm.
in order to create a real time dashboard, I need to show the leadership the real time status of how my features are performing, how many stories are we working on a day to day basis. But I understand I don't need minute to minute data, but I need at least data of the last 12 hours, for example, right? Um, in order to show, what's the real time scenario of how, what's the roll up performance of all the user story under a feature, or what's the roll up performance of my features under an epic, right? So,
Got it. Yeah.
so I
Sorry to cut you off. Yeah, but this is very much possible. So yeah, you can do that. Yes.
Okay, awesome, great, thank you.
Okay. Anyone else have any question? If not, we can wrap up our session today. And from next section onward, from next session onward, I will go deep around each um, and each services, or I will try to go with the use case, right, where I present a use case, and then I will show you, okay, how I'm using that particular service uh, in order to complete use case, right? Maybe in first, I have to come up with the use cases, and I'm also building one GitHub repository where I can include all those examples, which all those demos which I'm going to show you guys, so you can do a practice as well. And yeah, so hope to see you guys in next session. And good night, guys. Bye.
Thank you.
Thank you.